Hello and welcome to another video. This time we're doing Stats 2019 question 4, and it's another discrete random variables question. It seems to tie in, because I've been doing all these like linked up, it seems to tie in with, where's the last one I did? About cloud cover and octas again. In 2019 it was about cloud cover and octas again. Wow. Almost like they were trying to underline this point that it's mostly cloudy in the UK. But anyway, Magali is studying the mean total cloud cover in octas. I think I called them octals before as well. Apologies for that. I was clearly wrong. I was calling them octals. It's octas. So there we go. That shows my knowledge of the large data set is lacking. But yeah, it is for Loikers, which is in Scotland, in 1987, using data from the large data set. The daily mean total cloud cover for all 184 days from the large data set, because they only take it from May to October. Remember that. I believe it's May to October, March to October, I think, actually, are the months which they use. So there we go. Anyway, in fact, these kind of questions, they should make you. Can I just give you a bit of advice? In terms of like practicing for large data set questions, can I suggest that you get a copy of the large data set? I'm just going to quickly show you where I get them from. Large data set. And look at the front page of the Excel spreadsheet. Yeah, the front page tells you exactly what you need to know. That's what you should be looking at. It's really, really useful. First, you can see that Loika's in Scotland, but it tells you all the units and everything else. And as you can see, it's not much. It's May to October. That's what I'm mainly checking. May to October. So the summer months. But remember, that's winter when you're dealing with Perth or any other southern hemisphere cities. I think Perth is the only southern hemisphere one, though. Okay, so let's have a look. Let's get on with it. We've got this situation. Okay, they've counted up the cloud cover for each day and put it in a frequency diagram. Okay, find the probability, or estimate the probability, I think it should say here, that a daily mean total cloud cover of 6 or greater. Oh, because they're selecting one of these 184 days. They're not predicting into the future. Okay, so how many had a daily total mean cloud cover of 6 or greater? It's all of these. So that's 104 plus 28. So it's going to be 132 out of 184. Yeah. And yeah, you could cancel that down, I suppose. I'm not really that keen on doing it, but go on then. 130 half to 65, so 66. You can halve it again. 33 out of 90, 45, 46, I think. 33 out of 46. We'll check all these answers in a second. Okay, Magali is investigating whether the daily mean total cloud cover can be modeled using a binomial distribution. Okay. She uses the random variable x to denote the daily mean total cloud cover and believes that x is distributed binomially with 8 trials and 0.76. That's her estimate, I guess. So using Magali's model, find the probability that x is greater than or equal to 6. Now, this is annoying because I don't think I've got a calculator which does this in front of me, because I lent mine to a student who will remain nameless. Well, corridor. But yeah, he's got my calculator at the moment. So I'm going to have to just say what I would do. Your calculator does this for you, but what is the opposite of 6 or more? Because your calculator only works for less than or equal to on a binomial CDF, yeah? So you want binomial CD, yeah? But that will give you less than or equal to. Now, what is the opposite of 6 or more? It's 5 or less. So you want to do 1 minus the probability that x is less than or equal to 5. So in your calculator, you need to do 1 minus, and then you need to find the answer to the binomial CD. X is 5, N is 8, P is 0.76, and apparently that comes to 0.703. After you've done the 1 minus, it comes to 0.703. I think, let me just check that. Because like I say, I've got the answers right next door. So the first one we were right with, and the second one, yeah, answer rounds to 0.703. Notice they're always rounded to 3 sig fig, yeah? Or you can leave them as fractions, that's fine. Find to one decimal place the expected number of days. Why are they putting expectation in there when they took it out of the syllabus? How annoying. But anyway, I can show you how to do this. The expected number of days in a sample of 184 days with a daily mean cloud cover of 7, yeah? Well, let's find the probability of a daily mean, find to one decimal place the expected number of days in a sample of 184 days. All right, yeah, so they're asking us to estimate what this should be, basically, yeah? So we're going to do that using our binomial model, yeah? So what do they want? They want the probability that x equals 7, but this is that x equals 7. We'll find the probability that one day has a cloud cover of 7 octaves, yeah, and then we'll extrapolate from that for 184 days. So this is going to be a simple case of doing this on a calculator. You'll use binomial PD here. Because I've got a really old calculator, I'm going to have to do it the old way, so I'm going to very quickly do, what is this going to be? 0.76 to the power of 7 times by 0.24. Bear with me for 1 second. Times by 7, I think. Times by 8, sorry. Cool. Okay, I'm getting 0.281, but you can just do that on a calculator with binomial PD and find the probability that x equals 7. That's going to give you 0.281. So we would guess about 28.1% of the 184 days would have that cloud cover of 7. And so you're just going to do 0.281 times by 184. That's how expectation kind of works. So they want it to one decimal place, 51.7 days. Now look at this. That's remarkably close to the 52 we should have had. Explain why whether or not your answer to part B support Magali's model. So they support it. Supports it as 51.7 is very close to 52. And I'm guessing this is close to what it should be as well, because what was the probability that you get 6 or more? Well, under their model, it's 52 plus 52 plus 28. I haven't already worked this out. Yes, I have. Yeah, we get 33 out of 46. And what was 33 divided by 46? Is that 0.7 something other? That's 0.717, or should we say 0.72? Yeah, so we got 0.70 and 72, and then we got in the next one 51.7 days and 52 days. This supports it, as 51.7 is very close to 52, and 0.703 is very close to 33 out of 46. That's all they want with these kind of modelling questions. They're asking you, do they support it? Okay, there were 28 days that had a daily mean total cloud cover of 8. For these 28 days, is that true? Does it say in the table? Yes, it does. For these 28 days, the daily total mean cloud cover for the following day is shown in the table below. Yeah. So the next day, it was mostly cloudy as well, yeah, which seems to suggest that if it's cloudy, then it's likely to be cloudy the next day. Now, find the proportion of these days when the daily total mean total cloud cover was 6 or greater. Well, that's just going to be 5 plus 9 plus 9. So 18 plus 5, which is 23 out of 28. Yeah, and 23 out of 28, just in case they want it written to 3 sig fig, is 0.82. Yeah. Comment on Magali's model in light of your answer to part D. Well, this is not close to 0.7. And doesn't support Magali's, and therefore doesn't support Magali's model. Because you wouldn't expect those to change. And it's because weather isn't independent, really. It's dependent, yeah? As in, like, you've not got truly independent events, yeah? Let me just finish off that sentence. What I mean by that is, in a binomial distribution, which is what she's using to model it, you're supposed to have the assumption of independence between each trial. But if it's sunny one day, it's more likely to be sunny next day. And if it's cloudy one day, it's more likely to be cloudy the next day. And so we would expect that answer. Anyway, let's see if we're getting these all right. Good. Yep, okay. So, yeah, part A and B, part 1 are similar. The expected number of 7s matches with the number of 7s found in the data set. Some of Magali's models supported. That's good. Okay, 0.82 differs from this. Therefore, Magali's binomial model may not be suitable. There we go. Independence does not hold. They would have accepted that. And that's this question. Hope it was useful. Keep up the hard work. And, yeah, good luck in the exam.